Chapter 12. We'll be talking about liquids, solids, and intermolecular forces. The quote for this chapter is from Roald Hoffmann. It's a wild dance floor there at the molecular level. So here we have a photograph. This is a Canadian astronaut in the space station, and this is a very large drop of water in zero gravity. And I found a video.
The question is, if you get a cloth dripping wet without gravity and you wring it out, what's going to happen? What will happen to a wrung-out cloth? So, and it had to use equipment that was here on board the space station. We might have the coolest washcloths ever here on the space station. I'm going to show you. Here's one of our washcloths. And it's compacted. It's put down into this little tiny hockey puck so that it saves space. But when you open up a hockey puck and you pull out your washcloth, this is the one I'm going to use for the experiment today. And so when you open up your hockey puck and turn it into a washcloth, it was compressed in a great big vise somewhere. Okay, so here's my washcloth, like a magic trick. And now I'm going to get this soaking wet, and then we're going to see what will happen when we wring it out. Meredith and Kendra suggested that I dip this in a bag, but bags don't hold water in space, so instead I filled a water bag. This has drinking water in it. And I'm going to squirt a bunch of water into this washcloth. Okay, so here's a soaking wet washcloth. Get the microphone so you can hear me while I'm talking. And now let's start wringing it out. It's really wet.
You didn't expect that, did you? So those are Canadian school children watching.
It's becoming a tube of water. The water's all over my hands. In fact, it wrings out of the cloth into my hands. And if I let go of the cloth carefully, the water sort of has it stick to my hand. Okay, so the experiment worked beautifully. And the answer to the question is the water squeezes out of the cloth, and then because of the surface tension of the water, it actually runs along the surface of the cloth and then up into my hand, almost like you had Jell-O on your hands or gel on your hand, and it'll just stay there. Wonderful moisturizer on my hands. And the cloth doesn't really unravel itself. It just stays there floating like a dog's chew toy, soaking wet. Great experiment, worked perfectly. Meredith and Kendra, congratulations, great idea.
Now, I've been using Grammarly for years. Now, the great thing is Grammarly is free and easy to use. It not only helps you check your grammar, but also...
Great for you. We're so happy for you. Okay. Anybody have any questions or comments?
That was amazing. Black.
That was amazing, huh? Right? So, in this chapter, we'll be talking about intermolecular forces, and one of the things that results from that is surface tension, which is why the water does that in space instead of just flying all over the place. Intermolecular forces, what are those? These are attractive forces that hold atoms and molecules together, and they exist between all atoms and molecules. They are significant only at very short distances. They are responsible for the existence of solids and liquids. If we had no intermolecular forces, all substances would be gases. And then the universe would be a very, very different place. These intermolecular forces also play a big part in biochemical reactions in your body, so very important. In what state a sample of matter is it a solid, a liquid, a gas at a particular temperature, depends on the relative strength of the intermolecular forces compared to the kinetic energy that that substance has at that temperature.